This is question 8. In part 1, we're asked to solve for x between minus 180 degrees and positive 180 degrees. Tan of x minus 40 degrees is equal to 1.5, given our answers to one decimal place. The question carries 3 marks. The first thing I'm going to do is write that x minus 40 degrees will be equal to the inverse tan of 1.5. We're going to go ahead and find a principal value and then consider subsequent solutions. In the calculator, making sure we're in degrees mode, shift mode 3, we take the inverse tan of 1.5. This is going to give me 56.309, so we can write x minus 40 will be equal to 56.309 ... plus or minus 180n. So all we're doing is looking now at the multiples of 180 degrees. The tan curve cycles every 180 degrees, so subsequent solutions will be either 180 degrees on or backwards. So if we look at this one, the first one we can state now by adding 40 to both sides, we can say that x would be equal to the 56.309 plus 40, which gives me 96.3, and that is degrees, and that is to one decimal place. If I add 40 and add 180, I'm going to go outside the interval, yet if I add 40 and subtract 180, I will stay in the interval. So at this stage, I'm simply going to subtract 140 degrees from my answer and round that to one decimal place. That gives me minus 83.69 and so on and so forth. So we're going to have minus 83.7 degrees to one decimal place. So all I've done is considered subsequent solutions on from that point, and these are our two answers. In the second part, part A asks us to show that the equation sine theta tan theta is equal to 3 cos theta plus 2 can be written in the form 4 cos squared theta plus 2 cos theta minus 1 is equal to 0. The question carries 3 marks. Let's look at some trig identities. We know that tan theta will be sine theta over cos theta, and also we know that cos squared theta plus sine squared theta will be equal to 1. Or we could say sine squared theta is equal to 1 minus cos squared theta. So let's go ahead and use these identities and rewrite the equation. So I'm going to write this now as sine theta multiplied by tan theta. Well, I know that that's sine theta over cos theta. I'm going to let that now, or set that equal to 3 cos theta plus 2. Sine theta multiplied by sine theta is sine squared theta. I'm now going to multiply both sides of the equation by cos theta. That will give me 3 cos squared theta plus 2 cos theta. At this stage, I need to put the equation in terms of cos theta. So to eliminate sine squared theta, I'm going to use the identity here. We can state that 1 minus cos squared theta, which is sine squared theta, is equal to 3 cos squared theta plus 2 cos theta. I'm going to add cos squared theta to both sides and subtract 1, setting the left hand side to 0. We'll have 4 cos squared theta plus 2 cos theta minus 1 is equal to 0. So as required, I've stated the trig identities that I'm going to use, substituted them in and shown my workings. In part B, it says, hence solve for theta between 0 and 360 degrees, sine theta tan theta is equal to 3 cos theta plus 2, showing each stage of your working. The question carries 5 marks. We can use 4 cos squared theta plus 2 cos theta minus 1 is equal to 0 instead of this equation right here. So what I'm going to do is write this out. So we're going to have 4 cos squared theta plus 2 cos theta minus 1 is equal to 0. This is a quadratic equation in cos theta. Looking at it, it's not going to factor, so we can either complete the square or use the quadratic equation. What I'm going to do is take the values of a, which is 4, the value of b, which is 2, and the value of c, which is -1, and use the quadratic equation. So we can say cos theta will be equal to minus b, which is -2, plus or minus the square root of b squared, which is 4, minus 4ac, which is 4 times 4 times -1, all over 2a. So 2 lots of a is going to give me 8. This is going to give me a solution or solutions for cos theta. So let's go ahead and do this on the calculator. So we want now -2. So we've got -2. We'll start with the positive. We're going to have 4 minus 4 times by 4 times by -1, and that will all be over 8. So we're going to have now -1 plus root 5 over 4. So we'll write this in. -1 plus the root of 5 over 4, and then the other one will give us the negative. -1 minus root 5 over 4. Now if we look at this, we know cos theta must be between minus and positive 1. If we look now, we can see that the numeric value of -1 plus root 5 over 4 is a number between 0 and 1, so that's perfectly fine. And we will also see that if we change this over, this will also give us now minus 0.8. So both of these are valid. So just check, because if one of these is less than -1 or bigger than 1, they are not going to be valid solutions for cos theta. So let's go ahead now and go and find these values. So what we can say then is theta, and I'll take the positive, will be equal to the inverse cosine now of -1 plus the root 5 over 4. Now if we consider, we're solving here between 0 and 360 degrees. If I look at this right now, what I'm going to have with the cosine curve, I'm going to have one solution, theta degrees in, and then 1 theta degrees back from 360. So if we just look at the symmetry of the cosine curve, if I have one just here, I might have theta just here, then this one by symmetry will be 360 minus theta. If I have one just here, and let's call this x, then this one is going to be 360 minus x. So let's go ahead now and find the principal value when we have the positive. So theta is going to be equal to, and just writing this out, we need to give our answers to, we're not asked to give our answers to any level of accuracy, so I'm just going to use a calculator and take the inverse cosine of now the answer. So just plugging this in, we're going to have now 72, and therefore what we can say is 72, and we can say theta will be equal to 360 degrees minus the 72. So just plugging that in or working it out mentally, we can go ahead and write the second solution. So the second solution will be 288. So theta will be equal to 288. That's a bit lazy of me to use a calculator, but again, we found the value. So that now is when theta is equal to the inverse cosine of -1 plus root 5. We now need to consider theta is equal to the inverse cosine of -1 minus root 5 over the 4. And just going ahead and doing this in the calculator, we've got now inverse cosine, and plugging the values in, we've got -1, then we're going to have minus root 5, and that's going to be over 4. That's going to give us 144, so theta is equal to 144, and then we'll have theta is equal to 360 minus the 144. So that'll give us the two values. Let's go ahead and do that. So minus the 360 minus the answer, again being lazy here, minus the 144, and that will give us 216. So theta is equal to 216. So if we list these out, we've got now the 72, the 288, the 144, and the 216. So theta, and I'll put these in ascending order, 72, we've got 144, we've got 216, and we've got 288 degrees. So final answers, we have 4 of them, and again, it didn't say round them to a specific level of accuracy, as they were integer values.